Here we're going to look at example 3, add rational expressions with unlike denominators. There's going to be a lot of steps here. This is a great example because it shows pretty much everything that's going on. So kind of bear with me and hopefully we get through this without too much difficulty. So the question is, what is the sum of x plus 3 over x squared minus 1 and 2 over x squared minus 3x plus 2? Clearly they have unlike denominators. It's already been mentioned. So the first thing we want to do is we want to factor each denominator. So this first fraction we're going to write as x plus 3. X squared minus 1 is the difference of two squares. So that's going to be x plus 1, x minus 1. And then my second term, we're looking at the factor sum chart. So my numerator stays as 2. And then we want factors of 2 that add up to negative 3. So this will be x minus 1 and x minus 2. I mentioned it pretty much every time, but I'm not going to go into crazy detail or too much detail with the factoring because that's been kind of covered at length in multiple other previous videos. So if you do have questions on that, just look up the either the AC method, the factor sum method, anything like that, and you'll be able to factor those. Okay, so the next thing we need to look at, and we need the LCM. So whenever you're adding up fractions, we need an LCM. So I'm going to write this out here. Might write it a little longer than I need to, but we get the idea. So the LCM is going to be a combination of the terms from the denominator. So we have an x plus 1 here. There's no x plus 1 in the other one. I have an x minus 1, but that's repeated over here. And then we have an x minus 2. So I'm just going by colors here. But what this tells me is that there's going to be let's say three expressions or parts to my LCM. And they're going to be each of these ones that I've highlighted. So my LCM is going to be x plus 1, x minus 1, and x minus 2. And I'm going to rewrite that for both of the fractions. And once again, we're going to color code this. I'm missing, sorry, that should be an x plus 1. So with this x plus 1, we have our x minus 1. This is not cooperating with me today. And then x minus 2. So we've accounted for all of them. We have all of our pieces from this LCM. Now what's going to be very important is that since I've changed the denominator in both fractions in this case, I need to be careful about the numerator. So any changes to the denominator also need to be shown in the numerator. To do that, I need to ask myself, from here to here, what's new? What has changed? Well, the x plus 1 and the x minus 1 were already there, but that x minus 2 is brand new. So if it's new to the denominator, it needs to be new to the numerator. It needs to be introduced there. So we want to account for that. And now I need to do the same thing over here. What is new from here to here? Well, the red and the pink ones were already there, so that x plus 1 is my new expression. So I'm going to have 2 times the x plus 1 is that new piece. And this is where it helps to have a color coded so you can see, all right, what colors are new, and I don't have to get too hung up on the numbers itself. All right, so now you have an LCM. We'll say, updated our numerators so that they're, we still have some, what's the word I'm looking for? Equivalent expressions. So I haven't changed the value of anything. I've just really changed the appearance. Our next step, now that we have those LCMs, that common denominator, we can add up our numerators. And be very careful here. By adding them up, all I'm going to do is just write everything together. All right, and I'm going to write this as plus 2 times x plus 1. Since it's addition, I don't have to be crazy careful about my numerators. If this was, let's just pretend this was a subtraction problem, I would have to be careful on how I distribute that subtraction sign. All right, so just keep that in mind. We'll get to that in a later video. We'll do some subtraction problems with these. And then my denominator is just going to be the LCM. So the x plus 1, x minus 1, x minus 2. All right, and I'm just going to keep color coding that just to kind of keep track of all this. All right, from here, I now have one fraction, so I just need to work on cleaning everything up. My numerator, I can start combining like terms, I can start distributing, I can start multiplying everything out. This is going to be kind of up to you at the, the how many steps you make this kind of work out to be. Kind of stumbling over my words here. So what I'm going to do is I'm going to do multiplication, and I'm going to distribute or FOIL this, and I'm going to distribute this here. So I'm going to do all that in one step. Okay, so we're going to have x squared minus 2x plus 3x minus 6, and that comes from multiplying these two. I get that there. Let's write all this out. And then I'm going to distribute this 2 here, so that's going to give me a positive 2x and a positive 2. And my denominator is just going to stay the same. We're not going to do anything about that. So in case you're wondering where any of those terms came from. Moving forward from here, again, there's different steps. You need to start combining like terms. I'm going to show all the steps. As you get better at this, there's steps that you can kind of skip. So I'm going to have x squared here. I'm going to combine the negative 2x plus 3x, and that is going to give me a positive 1x minus 6 plus 2x plus 2. All right, and then my denominator is just going to be brought along. Next, I'm going to combine like terms again. So my numerator, just x squared. I have 1x and 2x. That will give me 3x. And then negative 6 and positive 2 would be negative 4. So we're combining those like terms. This is where these problems get a little bit annoying. Maybe you haven't loved this whole process before. But when we get to this final step, when we've combined all our like terms in our numerator, we need to check to see if this can be factored again, because there is the chance that we can simplify or reduce something out. So my numerator, I need to ask myself, are there factors, I've run out of highlighting colors, are there factors of negative 4 that add up to 3? So is this factorable? Well, in fact, it is. So this can be factored into x plus 4 times x minus 1. And that would all be over x plus 1, x minus 1, x minus 2. And now you might ask yourself, well, why did I have to do that? Well, the reason for that is I have this x minus 1 and this x minus 1, and those can be reduced out. Okay, so now that I've factored that, I can reduce those two. They kind of cancel out, they're treated as a 1, and we get x plus 4 over x plus 1 times x minus 2. And I can leave it like that. So there's nothing else I can cancel out. There's nothing else that can be factored. So this, after all these steps, that would be the sum of what I originally was given, those two fractions. So obviously there's a lot going on here. We're looking at LCMs. We're looking at adding up like terms. There's multiple times where we have to factor. There's a whole mess of things going on. And to add on top of that, we should always consider our domain. The domain, though, the good thing about this is it's pretty straightforward. We just want to look at our LCM, and that'll give us a pretty good understanding of what numbers are and are not allowed. So domain is going to be all real numbers, except whatever would make my denominator 0. And to do that, I'm going to look at my LCM, let's say over here. And what numbers will make that turn into 0? Well, negative 1, positive 1, and positive 2. If I plug those in, at least one of these, let's say parentheses, these groups is going to be 0, and multiplying by 0 will give a denominator of 0, which in turn gives an undefined expression. So just keep in mind that there is the domain that you need to look for, especially if you were to start graphing these or just looking at it in general. Sometimes you will be asked for the domain, so do keep that in mind. All right, I think that's it. I've done enough explaining for this problem. Just be careful. Once you get the LCM, make sure that you're matching things up. All right, this is the key step right here. All right, if you get this step correct, everything else is just kind of going to fall into place. Make sure that whatever is new in the denominator, from let's say this step here to this start step, if it's new in the denominator, you need to also introduce it to the numerator. And that's where I did the x minus 2 in the first fraction and the x plus 1 in the second fraction. And now I am done talking. It's the end of this video. Give number 3, try it a go, and see how you do.